you're unfamiliar with this Blockly language, it's essentially a visual programming language in which coding concepts are represented through interlocking blocks. It's a great low-code or no-code alternative for controlling robots. So we see that Raza is putting some pieces together. The green block that you see is like a for loop, but everything inside it will repeat however many times that she says. The blue block is a move block, so it basically moves the arm, the robot's arm to a certain position. The purple block is for the gripper that you saw here. It will open or close. So essentially, she's trying to move the arm to one location, open the gripper, then move to a different location, close the gripper, and then release the gripper. And as she's putting that together, I can actually change my video camera so she can actually see the robot. So now, right now, she's just putting some coordinates in, so they move to the right location. And remember, she's doing this from India, so. Alright, so she's going to repeat this sequence 5 times, so pay attention to the robot. And once she launches it, you'll see the robot is actually moving according to her blocking commands. No code involved. So Raza also has access to another interface that lets her have finer control over the robot. We have shared these cameras, which points directly at the robot so she can see what's happening. This control panel lets her control the robot in Cartesian coordinate systems, so like the X, Y, and Z. Or she can control each individual joint, the movable components on the robot. So right now she's like pressing back, so it moves the arm back, rotating the arm left and right. And we'll just let Raza play with the robot so I can introduce RETA. RETA stands for Robotics Educational Teaching Agent. This is an exciting new development in evolution of STFT's mission to provide not just education for all, but also to democratize the tools that can help other educators with missions that align with their own. So RETA lets us do exactly what you saw. It lets us control a robot, like Doba here, from anywhere in the world. We hope to open RETA to other collaborators among many academic and industrial research groups that operate at the intersection of robotics and artificial intelligence. So with RETA, we plan to knock down barriers in robotics such as cost, by giving opportunities to learn, code, and build robots through RETA. But before we can get there, however, we need to tackle some technical challenges. One is, you may have noticed, it takes a while for a robot to move after Raza issues a command. Other challenges include providing students with streamlined access to robots, as well as adding more robots. So once we have no longer have the need to manually provide students with access to RETA, there will be greater demand. Overall, we want to make robotics accessible to everyone, and RETA is one of the ways we're doing that. We are working to enable all devices, be it a smartphone or a laptop, computer, as long as access to internet. So we hope you enjoyed our robotics demonstrations today, RETA as well as the computer vision, AI, and of course the MBOT demos by some of our students here. The field of robotics is very exciting because there are so many applications to robotics. However, as many students here know, robotics combines many academic disciplines like electrical engineering, computer science, and mathematics, to name a few, which can make it very challenging for robotics. So not to mention the challenge of getting your foot in the door because of lack of opportunities. We all saw today what young minds can accomplish given the tools. So we'd like to thank OFA and Dr. Albert Hu for making all this happen, and also thanks to Code Tenderloin and LinkedIn for having this, as well as RASA for donating their time to demonstrate RETA. I know it's pretty late in India right now, so our time is pretty well appreciated. Thank you.